History records the space race as a sprint to the moon. We remember the 1960s as a competition to plant a flag in the lunar dust, framing space as a high-stakes frontier for scientific prestige. But inside the Kremlin, the moon was viewed as a preliminary testing ground. Declassified Soviet documents reveal an objective far more ambitious, establishing a permanent military presence by plunging into the clouds of Venus. This diagram shows why the plan seemed impossible. On the surface, Venus hosts temperatures of 475 degrees Celsius, hot enough to melt lead, and an atmospheric pressure 90 times greater than Earth's. It is an environment that destroys almost everything it touches. Why would the Soviet military-industrial complex commit its most advanced engineering to a world that crushes titanium and melts electronics? While NASA saw an uninhabitable hellscape, Soviet planners saw a strategic advantage. To them, the hostility of Venus provided a natural, unassailable shield for a permanent planetary fortress. Under Leonid Brezhnev, the Soviet space program operated as an extension of the military services. Funded by the Ministry of Defense, planetary exploration was recontextualized as a search for new theaters of operation. They applied the ancient concept of the high ground to the inner planets, theorizing that control over the orbit of Earth's closest neighbor would offer a decisive advantage in long-term reconnaissance. Planners identified 3 specific tactical goals. Venus could serve as a deep space surveillance hub, its atmosphere would protect a garrison from cosmic radiation, and its gravity well allowed the USSR to launch kinetic projectiles toward Earth at velocities that would bypass Western tracking and interception. Conquering Venus was a strategic move to secure a command post that functioned outside the reach of the United States terrestrial and lunar defenses. The robotic Venera program operated as a tactical vanguard to test survival technologies in extreme conditions. Designers utilized massive over-engineering, building landers around a spherical titanium pressure vessel with shock-absorbing crush rings, ensuring the payload remained intact even during high-velocity impacts. Transporting these heavy modules to the inner planets required the N-1 rocket. This super heavy lift architecture was the only vehicle capable of moving the massive tonnages required for an interplanetary military outpost. The center of this fleet was the TMK, or Heavy Interplanetary Vessel. This 75-ton craft was designed to sustain a crew of 3 during a multi-year transit through deep space. This diagram shows the SOZH life support system intended for the TMK. It utilized blue-green algae reactors to create a closed loop, converting carbon dioxide and crew waste into breathable oxygen, and recycling up to 80% of the mission's food requirements. Solving the transit was only the first half of the Soviet mandate. The more difficult problem was how to build a base once the crew arrived. The Soviet blueprint bypassed the melting surface entirely. Instead, they planned to deploy an aerostat structure that would float steadily 50 kilometers above the ground. This cross-section highlights a sweet spot at 50 kilometers, where temperature is 20 degrees Celsius and pressure is 1 atmosphere. Because Venus's CO2 atmosphere is so dense, a habitat filled with Earth-standard air is naturally buoyant, acting as a lifting gas. Above these floating colonies, the Soviets planned the MKBS, a 250-ton nuclear-powered command station that would serve as the hub for all Venusian operations. To protect the outpost, engineers developed the Sheet 1 defense complex. This was a 23mm rapid-fire space cannon designed to destroy incoming American interceptors or disable Western reconnaissance satellites. The resulting architecture envisioned a self-sustaining colony in the clouds, supported by an orbital station with the firepower to defend Soviet interests from deep space. The Venusian dream ended before it left the pad. 4 consecutive failures of the N-1 rocket and a tightening national budget forced the Soviet leadership to reconsider their interplanetary priorities. The deaths of the Soyuz 11 crew in 1971 further shook the program's foundation. By 1974, the Kremlin officially canceled the crewed planetary mission, effectively ending the quest for a Venusian fortress. While the military outposts never reached Venus, the technology did not go to waste. The modular systems and life support units originally engineered for the Venusian colony became the basis for the Salyut space stations in Earth orbit. These designs evolved through the Mir station and eventually formed the core of the Russian segment of the International Space Station. The hardware currently orbiting Earth is a direct descendant of the modules intended for the Venusian atmosphere. Modern space exploration relies on modular systems and long-duration habitats originally built for a classified Soviet war machine. Today, we live in the repurposed shells of a fortress once destined for the clouds of Venus.